Welcome back to MLT 115. Today we're going to be doing some practice problems to go along with the spectrophotometry lecture. We're going to be working problems in your textbook on page 174. For these problems, you will need a simple scientific calculator. I'm going to be using the Casio FX260. Again, that's the Casio FX260. Again, this is the scientific calculator. You can get them for about $10 off of Amazon or at Walmart. If you're looking for a Texas Instrument brand, the number would be a TI-30X, or you can just simply use your calculator that's on your computer. You just need to make sure that's in scientific mode. Now, when you're taking your exams online, you will not be able to use the calculator on your cell phone, so bear that in mind. So you might want to invest in a simple calculator with a log key if you don't already have that. So let's go ahead and work through some of these problems. We will be solving for absorbance. It's one of those formulas that we learned in our lecture. So it's going to be A equals negative log T. That's what we're going to be working with today. Before we get into working our problems on page 174, we first need to talk about how we actually need to plug in the information into our calculators in order to solve these formulas. So that's why we are given the information in the top left-hand corner right here. It's because it's telling us how most likely you're going to type it into your calculator. We're going to be working with the A equals negative log T formula. And some calculators are different than others, but I found most often that the calculators that I've worked with are going to use the where you put in the T first and then you're going to hit the log key and then change the sign at the end. So that's most likely what your calculator is going to need you to do. That's what my little Casio FX260 requires that I do. That's what this scientific calculator here on the screen requires me to do in order to solve our problems. But anyway, that's what that whole little blurb up there in the top left-hand corner is just telling you how to plug the information into your calculator. And that's actually from page 169 in your textbook. So let's go ahead and try to solve some of these problems from page 174 in your textbook. Let's start off with problem number 19. The directions say convert the following percent transmittance values to absorbance. So number 19 gives us 80% transmittance. Again, we're trying to do from transmittance values to absorbance. So we're trying to solve for absorbance. And again, we're using A equals negative log T. That's the formula that we're going to be using. Okay, let's look at number 19. It gives us 80%. So 80% is our transmittance. We can't work with a percentage in our formula, so we're going to have to convert that percentage to a decimal in order to put it into our formula. And the decimal is always at the end of the number, so we're going to have to move the decimal over 2 spaces to the left. And that's going to give us 0.8 to work with. So we're going to end up with A equals negative log, and the T is now 0.8. And that's what we're going to be able to use and plug into our calculators. So remember, when we're plugging into our calculators, we have to plug in our T first, then hit our log key, and then we're going to have to change the sign once we find our answer. So our T is 0.8, so 0.8 into our calculator, and then we're going to hit our log key, and that's going to give us our answer of negative 0.0969. We can actually round that off to 0.97. So our A is going to be, or our absorbance is going to be equal to 0.097. So that's going to be our answer. Again, just to review how we plugged it into our particular calculator here, is we put in our transmittance first, then we hit our log key, and then we had to change our sign, because that's what it said. We had to change our sign of our answer in our directions. Now, if you're using a scientific or a fancier, more advanced scientific calculator, you might be able to use parentheses and plug it in just exactly how the formula is written and not have to do the T first. But just know different calculators might differ on how you have to plug it in, or you may not have to change the sign. But if you're using a simple little scientific calculator, you're more than likely going to have to put transmittance in first and hit log and then change your sign. So let's look at our next problem. Number 20 gives us 20% for transmittance. And remember, we're working with the formula A equals negative log and T. And 20 is 20% transmittance. Remember, we cannot work with a percent, so we got to convert that 20% to a decimal. And how we do that is we move our decimal over 2 spaces to the left. So our T is going to be 0.2. So when we plug that into the formula, A is going to equal negative log 0.2. So at this point, we can plug everything into our calculator. And remember, we have to plug in our transmittance first, which is going to be our 0.2. So if you plug in 0.2 for our transmittance, hit our log key, and you're going to get a negative 0.6989. And if you round that off for number 20, if you round that off, you're going to end up with negative 0.699, and we need to change our sign. So our answer is going to be 0.699 for our answer. And that's going to be our absorbance. Let's look at problem 21. 21 gives us 50%. So let's plug all that information in. Again, A equals negative log T is our formula, and 21 gives us 50% transmittance. So if we change our 50% to a decimal, we're going to end up with 0.5. So our A is going to equal negative log of 0.5. So that should be our formula. Now we need to plug our formula into our calculator, and we're going to have to clear our calculator out from the last problem. So our T is 0.5, so 0.5, and we're going to hear a log key, and it gives us the answer of negative 0.31, excuse me, negative 0.301. So we need to change our sign. So 21, the answer for 21 is going to be 0.301. Now look at number 22. We have 100% transmittance for number 22. Again, we have to change that percentage to a decimal. So we're going to move our decimal over 2 spaces. So we're going to end up with 1.0. So when we plug that into our formula, A equals negative log 1.0. And now we can plug it into our calculator. So plugging in 1.0 for our T or our transmittance, hit the log key, and the answer is 0 for absorbance. So 22 A or absorbance equals 0. So if you think about it, if you have, we started out with 100% transmittance, so all the light is going through the sample. So is anything being absorbed? No, it's not. So it makes sense that we have 0 for the absorbance in this case. Let's look at problem number 23. 23, we have 10% as our transmittance. Again, we got to change that to a decimal. So we're going to end up with 0.1. That's our T. So if we plug all that into our formula, A equals negative log, and T is 0.1. And now it's just a matter of plugging it into our calculator. So 0.1 log is negative 1. So we've already figured out we've got to change our sign. So 23, if it's negative log and we got to change our sign, A is going to equal 1 for absorbance. The very last example I want to talk about and show you is an example when we're given our transmittance as a decimal. So let's see what that would look like. An example where transmittance is given as a decimal. So T equals 0.39. Okay, so all the questions or all the problems we've looked at previously, number 19 through 23, all of our transmittance were given in percentages, and we had to convert those percentages to decimals in order to plug it into our formula. Well, guess what? This is already given to us as a decimal, so we don't have to convert anything. So our T can go straight into our formula. So A equals negative log, and our T is 0.39. So now it's just a matter of plugging it into our calculator. So we can plug our 0.39 into our calculator for T and here our log key. So 0.39 for T, hit log, and we end up with negative 0.4089, and that's going to round off to be A is going to equal 0.409. And remember, we're going to change that negative to a positive. I hope all these examples give you an understanding of how to use the calculator and the log key to solve these equations for absorbance.